So we've been studying equations for a while, but now we're going to talk about something called inequalities. Inequalities are a little bit different than equations because they are not always the same as something. It's more of a comparison. Inequalities have four general symbols: less than, greater than, less than or equal to, and greater than or equal to. Alright, so remember, less than, greater than, less than or equal to, and greater than or equal to. And all of these words just tell us how numbers relate to each other on the number line. So here's a number line. Let's look at a couple things and see how they relate to each other. Let's say we have the number 5 and we have the number 10. If we find those on our number line, here's the number 5, here's the number 10. How does 5 relate to 10? 5 is less than 10, so we could put the symbol in between there. 5 is less than 10. Let's try another pair of numbers. Let's say we had -3 and -7. This one's a little bit tricky. So let's find -3 on the number line. And let's find -7. If we look at the number line, -3 is to the right of -7. So -3 is actually greater than 7. The bigger the numbers are to the right. The smaller numbers are to the left. So let's look at another couple pairs of numbers. Let's look at 0. 0 is good. He's right in the middle of my line. Let's look at 0 and 2. So first thing we need to do is we need to find them on our number line. So here's 0. Here's 2. 0 is to the left, and so 0 is less than 2. Alright, let's look at one last example. Let's look at the number 5 and the number -1. So now we need to find those on our number line. And 5, oh, we already used 5. I'm going to make this purple. And -1. 5 is to the right, so 5 is greater than -1. So again, these symbols just tell us how things relate to each other on the number line. So we talked about another couple symbols as well, and they had a little equals to attached to them. So let's look at how those changed things. Let's say we had 0 and -2. And I'm going to say 0 is less than or equal to to 2. And I want to know if this is a true statement or not. So let's look at 0 here and 2. So we have two options. 0 can be less than 2, or 0 could be equal to 2, and this statement would still be true. So in this case, 0 is to the left, so 0 is less than 2, so this is true. Alright, so let's look at another one. Let's say we have 0 is less than or equal to 0. Now, if we look for 0, and there's 0 again, we ask ourselves, 0 could be less than 0, which is not true, but 0 could also be equal to 0, which is true. So again, this is a true statement. Alright, so let's think about something else. Let's say we had 3 is less than or equal to -9. So 3, -9. Is 3 less than -9? Remember, less than means to the left. Is 3 to the left of -9? Nope. Is 3 equal to -9? No. So this statement is a false statement, and we cannot say that this was true. 3 is not less than or equal to -9. So these are just some of the basics, and we're going to look at this with variables now. We had just numbers, now we're going to compare variables with our number line. Alright, so looking at our number line, remember again, smaller things are to the left, larger things are to the right. So let's say we had the statement x is less than 3. Before we do anything with the number line, I just want you to stop and think, what are some numbers that are less than 3? 2 is less than 3. Negative 5 is less than 3. Negative 1.19826, and so on and so forth. Those are all less than 3. I'm going to put a dot at 2, and a dot at negative 5, and a dot sort of around that crazy 1 point whatever number. And I'm going to put a circle here at 3, because this is what I'm comparing to. I'm saying x, some number I don't know, is less than 3. So look at where we plotted the 2 and the negative 5. They were all to the left. Now, we could keep thinking of lots of other numbers that made this statement true, but instead, let's take the easy route and let's just shade the number line this way. So this is how we would graph the inequality x is less than 3. We shade to the left for all of those numbers that are less than 3. Think about it. I could pick out any number down there. I could say negative 7. Is negative 7 less than 3? Yes, it is. Now we could also think about those numbers on the other side. Let's say I had 8. I'm going to pick 8. That was gross. Is 8 less than 3? No. So that is not true, which is good because that's not where I shaded. Alright, so let's try another graphing one. This time let's look at y is greater than or equal to negative 2. Again, I'm going to ask you to think of some numbers that are greater than or equal to negative 2. So greater than, bigger. 0 is bigger, right? What else is bigger than negative 2? 100 is bigger than negative 2. Now, remember, y can be greater than or equal to negative 2. So what's another number that would satisfy this? Negative 2 actually would. Now we could list out lots and lots of numbers, but let's at least graph what we know. We have the point 0, we have the point 100, way out here somewhere, and then negative 2. Now I put a circle there when I had just the 3, and but this time I can include negative 2, so I'm going to color it in. Now all of these numbers are to the right, so when we graph greater than, we shade to the right. So here we have the graph of y is greater than or equal to negative 2. And we could pick anything we wanted to over here. 5. Is 5 greater than or equal to negative 2? Yes, it is. So we made the correct graph. So just a quick review. When you're graphing something like x is less than a number, then what happens is you shade to the left because all the numbers are smaller on the left. If you were graphing something that's x is less than or equal to a number, yes, you shade to the left again, but you also need to remember that you need to have a closed circle there, colored in, because it includes that boundary point. If x is just less than a number, you have what's called an open circle because it does not include the boundary point. Now if we go to the other side, the flip side, we have x is greater than a number. Then this time we're shading to the right because we're looking for the bigger numbers. And the boundary point is not included, so we keep it open. We're going to graph x is greater than or equal to a number. Then we are going to need to color in that boundary point, but still shade to the right because those are all the bigger numbers. So let's look at two last little practice problems. Let's use the variable a. Let's say a is greater than 6. So if we're going to graph a is greater than 6, we're going to need to mark our boundary. Here's our boundary, 6. Can a equal 6? No, so we have to keep it open. And we're going to shade to the bigger numbers, and the bigger numbers are to the right. Now, let's try one more. Let's look at one more less than. Let's say B, because I'm at that area in the alphabet, is less than or equal to 0. So, I need to mark my boundary point. That's 0. And could B equal 0? Yes, it could. So I'm going to color it in. And we want to shade where all those numbers that are less than 0 are, and those are to the left. There we go. There's one last type of graph I want to look at, and that's called a compound inequality. It has more than one part associated with it. So let's look at the compound inequality. -4 is less than A is less than or equal to 5. We can look at this in a couple different ways. I want to start out with that A. A is in between -4 and 5. So let's mark those two boundary points on our graph. -4 is one boundary point, and 5 is the other boundary point. Now, is it okay for A to equal -4? No, the symbol doesn't have the equal sign with it, and so I need to keep that circle open. But let's look on the other side. It says A is less than or equal to 5. So could A equal 5? Yes, it has the equal sign part, so I need to color that in. Now A is between these two things, so I would shade in between. So let's try one other of these. We're going to use the same graph since I have all these cool colors. Let's do 3 is less than or equal to W is less than or equal to 7. So again, this says that W is between 3 and 7. So let's mark our boundary points. I'm going to put a circle at 3. I'm going to put a circle at 7. Now, could W equal 3? Yep. Could W equal 7? And W is in between, so I'm going to shade in between. Think about all the numbers that W could be. W could actually be 4, and it would be true. W could be 6, and it could be true. W could be 5.382, oh, that's a 7, but whatever. It could still be in there because it's between 3 and 7. It satisfies the inequality.